In this video, we're going to be looking at perimeter. But before we can even start looking at perimeter, we need to think about what measurement is. And measurement is a way that we can quantify different values, different sizes, lengths and amounts of something. And to do that, we need to measure them. So if we're looking at temperature, we might be using our thermometer. If we're looking at volts, okay, we might be using our voltmeter. And if we're looking at measurement, we've got our ruler there. Now in this unit of perimeter, we are looking at units of distance. So we'd be using our tape measure or ruler. Now, when we're looking at distance like we will be, we are looking at units of distance, okay? So we're looking at millimeters, centimeters, meters, kilometers. If we're looking at them in the sense of area, we'd be looking at them squared, so millimeters squared, centimeters squared. If we're looking at volume, we'd be looking at millimeters cubed, centimeters cubed, meters cubed. In this unit of perimeter, we are looking at the distance, so the basic millimeter, centimeter, meter, kilometer. Now there's a range of different tools you can use to measure distance, okay? And it depends of the size of the distance that we're measuring as to what tool we would use. So we could be using our ruler or our tape measure, okay, for smaller distances. We could be using our measuring wheel, okay, for those kind of mid distances. Or we could be using the modern GPS kind of equipment for bigger distances. Okay, now before we even get to measuring perimeter, we need to think of a few things, and these are dimensions. Now you'll quite often hear of the terms length, width and height, okay, and sometimes students get really panicked about making sure they pick the right dimension for the shape. At the end of the day, it's about knowing that your shape has different dimensions and where those dimensions are. If you muddle up the length by the width, it doesn't actually matter, as long as you've only got one length and one width. Okay, so they are interchangeable. Okay, now another thing we need to think about is conversions, because quite often you'll be looking at a problem and it could be measured in, say, centimetres and metres, and you're going to need to convert one value to another, because any calculations you're doing involving distances must be in the same unit. So you'll see on the diagram here, if we're converting from a small unit to a large unit, we need to divide by the value above there. So for example, if we've got 50 millimetres and we want to get that to centimetres, okay, we need to divide that 50 by 10. There we go, 50 divided by 10 is 5, so 50 millimetres is the equivalent to 5 centimetres. If we're looking in the opposite direction, okay, say we've got 10 metres and we want to work that out in centimetres, okay, we have got to multiply our 10 by 100. So 10 times 100 is 1,000. So what does that tell us? 10 metres is the equivalent to 1,000 centimetres. So conversions are really, really important when we're looking at units of measurement, because we must ensure we're always looking at the same unit. You will notice at the moment I'm only looking at length. To the right hand side there you can see conversions for units of area. I look at area in another video. Alright, so let's think about perimeter. Now, perimeter is the outside of a shape, the area of the outside of a shape. So you'll see me here and I'm running around this paddock here. Now, perimeter is really important for farmers, architects, engineers, because if they're working on large objects, they need to know that outside measurement of it. So for example, a farmer might be putting up a fence. He needs to know the area of the paddock to be able to build that fence. If an architect is working on a sports stadium, they need to know the perimeter of the sporting field to be able to put the stadium in. Another perimeter, here I am running around the perimeter of Australia. What a beautiful trip that would be at the moment. And here I am looking at the perimeter of a square. Now we know that on a square all our outside lengths, so our lengths are all the same. So we would work our perimeter out as P equals A plus A plus A plus A. You guys know with our algebra that we could actually say P equals 4A for that. So 4, you'd only have to work out 1 and multiply that by 4. We will be looking into this in further detail in some videos shortly. Here we've got a rectangle and I'm running around the outside of that rectangle. Okay, so our perimeter would be the width, add the length, add another width, add another length. And we can write that out as a formula of P equals 2 times L, because we've got 2 lengths, plus 2 widths, 2W. So here we've got some other quadrilaterals. And each of these you could work the perimeter out for, the outside shape. So we've looked at rectangles and squares. Here with our parallelogram, we would have 2 lengths and 2 widths the same. Okay, so that would be the same formula as our rectangle. Rhombus has got 4 sides, all of the same length. So that would be the same formula as our square. Our trapezoid. Now with this, we know we've got 2 parallel lines, but other than that we don't know very much at all, so we'd need the measurement of each side. And then our kite, we've got, you could say 2 lengths and 2 widths that are the same. You might say those sides are A, and this is B, so you've got 2 B's and 2 A's. Okay, so if I was finding the perimeter of this triangle, okay, you'll see that it's in miles, not kilometres. Just always bear in mind there are other units of measurement, so what we call our imperial units of measurement, and you can always find conversions from imperial to metric on the internet. Okay, so here I am running around this triangle. I'm going to run 6 miles, and then I'm going to run another 6 miles, and then I'm going to run 3 miles to basically get back to that point. So how many miles am I going to run in total? I'm just going to add these up. Okay, so I've got 12, 15 miles in total, and I'd run that in pretty good time. So that shape that I was running around just now in miles is actually an isosceles triangle, and if you think about it, the area of the perimeter of an isosceles triangle then would be 2A, because 2 lengths of the side plus B. If we had an equilateral triangle, then we'd just it would be P equals 3A, because the sides are all equal. Things get a bit tricky when it comes to circles. There's lots and lots of features of a circle. Okay, and in this diagram we've got C, that's our circumference, and we'll be talking a lot more about this. So in circles, the perimeter is called the circumference, just to confuse us. Okay, this blue line across the middle, this is what we call our diameter. This is the measurement that cuts right across the middle of our circle. And the red one here, this is our radius. And our radius is half of our diameter. And all of these come from this central point, which is called our origin. And if you think about it, the central point where our x and y axis cross on our Cartesian plane is also called the origin. So the centre of our circle is called the origin, and we'll go more into that in the video on circles. But at the moment, we just need to remember these key terms: circumference, which is the perimeter, diameter, which is cutting right across our circle, and our radius, which is half of our diameter. Now, when it comes to circles as well, we need to introduce this value known as pi. Now, pi is what we call a mathematical constant. Okay, so anytime you see that symbol for pi, we always use the value 3.14. Now, as you can see, it's actually a longer value than 3.14, but we round it up because you're not going to write the entire value of pi every time you use it. Your calculator has a pi button, which you can just press and it will calculate things using pi. Now, pi is defined as the ratio of a circle's circumference to its diameter. We'll look a bit more at what that means. But what we just need to know for a moment is pi is 3.14. Remembering the reason that is because this value after the 4 is a 1, so we do not need to round the 4 up. So pi 3.14. Okay, so if we think of our circle in this unit that we're looking at perimeter on, I am going to run right around this circle to find the perimeter of it. And in circles, as I've already said, we call this circumference. Okay, so our calculation for finding that out is the diameter times pi. Okay, we're going to look at this in a bit more detail in some examples shortly, but if you're looking mathematically for a second, circumference equals the diameter times pi. Okay, so now we're going to look into some examples, and I'm going to be using some ribbon to work with me to find out some perimeters.
In this bit, we're going to find the perimeter of this heart. So I'm going to go measure it with my ribbon and then measure the length of the ribbon that surrounded the heart. So the perimeter is 27 centimeters. Here we're looking at the perimeter of this book. So again, I'm measuring it with my ribbon. However, because the book's a regular shape, although we found the perimeter there is 59 centimeters, we can actually measure this with our ruler, whereas the heart was a bit harder. So we've found out that one length is 15 centimeters, the width is 15 centimeters. It's looking like this book may be a square, which it is. Okay, so all those sides make 60 centimeters. So we could say 2 lengths and 2 widths, okay, and we can use our perimeter formula with that one. We could say 4 lengths as it is a square. Here we've got our rectangle, our book. So we're using 2L plus 2W. So we've got 25.8 plus 19.2 by the looks of it. So we're working that out, and that's giving us a perimeter of 90 centimeters for our maths book. We can write that out in a different way. We could say 2 lengths plus 2 widths. Okay, and does that give us the same answer? Yes, it does. All right, here we're looking at the perimeter of our circle, but we know that's called our circumference. I'll put a mark on there. I'm going to measure it with my ribbon. I'm going to measure my ribbon. I don't think this is going to be too accurate looking at those wobbles in the ribbon, but it made 23 centimeters. I can measure that by rolling the circle around as well. It also makes 23 centimeters. Now let's try doing it using our formula that we learned earlier. So we know it's pi times d. We've worked out our diameter by measuring as 7.5. We're now working that out. Now that says pi is 3.06, so obviously our 23 wasn't too accurate. Now let's work it out using our calculator and pi. So we've got pi times 7.5. Our circumference is 23.56. That's why it wasn't very accurate. My measuring wasn't brilliant. And here we're measuring it out just using another formula, which is 2 pi r. So to find the radius, we've got to divide that diameter by 2, okay, which is 3.75. 2 pi times 3.75 gave us the same answer. Now we're looking at some tricky perimeters here. So first up, our calculator. It's not a regular shape, so in that case we could still use our ribbon. Okay, so that made 48 centimeters. Here I've got this tricky shaped book. Okay, now for this you've got to really make sure that you get your ribbon or string into every crevice as such to make sure you get a true perimeter. then you need to measure it out. Again, it's not going to be the most precise method, but it may be the best you can do with some shapes. So 82 centimetres. Here, this T shape, well, hang on, we've got some squares making this T shape. We've got 7 sides, okay, and we've got 1 long base as such. So 7 times 3 plus our 9. So our perimeter of our T shape was 30 centimetres. Here we've got an L shape. We've got 4 lengths and we've got 2 bases or sides. So we're measuring them out to find our total perimeter of 24 centimetres by the looks of it.